So with our pullback car, we have pulled it back, and once we've done that, we believe that energy is now stored in. It's definitely stored in the car, but we'll be even more specific. We'll say it's stored in the spring. And we could provide proof of that if we opened up the car. What would we notice about the spring? It would be wound up very tight. When we let go of the car, there is another flow of energy, so that the energy that was stored in the spring is now transferred into what other kind of energy? Transferred to kinetic energy. And so that kinetic energy is energy that belongs to the car. So we show that with this arrow here. Now then the car travels along for a little while, and it eventually stops. Does it have any more kinetic energy?
No.
So the question is, where did that energy go? Think of a real-life car. So you have all of this energy of motion because you're driving along the road, and then later on, we see that the car is stopped. So where did that energy go?
Ground.
Well, why did the car stop?
Friction.
Where? What part of the car helps to slow it down?
The wheels and the brakes.
The wheels and the brakes. In fact, if the car just stopped and you were very curious but foolish, and you looked at the wheels, because usually you can see the brake pads through the rims of the cars or just behind the wheel. If you were foolish enough to touch the brake pads, they don't do this, what would you notice? They would be very hot. So the energy that was stored in the spring was later on stored in the motion of the car, and now it is stored in what form?
Heat.
In thermal energy. And that's equally true with our pullback cars. Even though there's no brakes on them, they don't need brakes just because there's so much rubbing of the internal parts of that car that they heat up and the energy flows from the motion into the thermal energy. So if we wanted to draw a separate flow diagram for question number 5, what would it look like? It would look just like this. So the energy flows from the spring to the car, and then it just stays in the car, but it's changed from kinetic into thermal energy. So the diagram itself wouldn't look especially different. But if you're talking about a real-life car, okay, you could have your engine, the car, and the brakes. And so you can show, okay, first that happened, the car speeds up, but then this happened, and so the brakes are now really hot, and the car is no longer moving. Okay? Now, one of the challenges for understanding energy is that it can often be stored in these very difficult to find forms or storage mechanisms. Heat or thermal energy is a good example of that. And that's why it took 150 years after Newton for people to really get a solid idea of what energy is. Because it can be very sneaky as it is stored in these different ways.